So let's recap. So far what we've done is blink an LED, output data to the UART and read in from an ADC and read that data in. So now what we can do is talk about interrupts. Now interrupts are really important because whenever you're developing a low powered embedded device, you don't want the device on all the time and you don't want it sampling all the time. So what tends to happen is you're reading a sensor and the sensor's set up to read and it'll continue sampling and storing the data, and eventually all that data will be ready to process because your sensor will have run out of space. So what tends to happen is the sensor can ping the microcontroller and let it know that data is ready, and it does this using a thing called interrupts. Now interrupts are basically telling the microcontroller to interrupt any code that it's running and to process this data that is of utmost importance, and then it reverts back to where the code was running. So what we can do is print out a message every second or every 100 milliseconds that says hello world, and while we do that we can set up a user interrupt. So there's a user button on the Nucleo board, on my Nucleo board, so we'll connect that to an interrupt, and while there are messages being printed out, we can interrupt the main flow of the program, print out a message from our interrupt function, and then return to our main function here. So let's do that. So we need to go to our IOC file, and what we need to do is pick the pin that our button is connected to. So we actually need to go to the schematic for that. So my board has two buttons. So this is just a reset button, which is B1. There are two buttons, so we don't want to program that because we don't really have control of that. But what we want is this user button B1, which is connected to PC13. So the way this button is set up is it's pulled high. So this button will always, or this pin, excuse me, if we read it, it'll always see 5 volts or 3.3 volts or whatever VDD is, but it's basically set to high. And whenever we press the button, this pin will be pulled low. So that's important to know for when we're setting up our interrupt. PC13, if we go back to our IOC file and go to PC13, which is this one, and if we come down and select GPIO XTI or XI, so GPIO XI is GPIO external interrupt 13, so click that and then you can see it's appeared here. So what we can also do is go to this NVIC. This is basically just an interrupt table, and what we can do is enable it here. And if we go back here, and if we go to the NVIC, and then hit this code generation bit, what we need to do is generate this first, and I'll explain why we need to do this in a minute, and then we'll come back and untick these. Maybe we just untick that one, I can't remember, but we'll untick a few of these, but we need them ticked for now. What we can also do is change this to button. So that's now changed to button, and what we also need to do is set this GPIO, let me just widen this. So it's set to an external interrupt with a rising edge trigger. So if we click on this, what we want this to be is an external interrupt mode with a falling edge, because whenever we push the button, the pin gets pulled low, so it'll see the falling edge rather than the rising edge. So we want to select a falling edge, and we want to also, it doesn't really matter about that, I don't believe. We don't need them pulled up or down. We just need it selected as a falling edge trigger detection. So what we can do is test this is working, go back to our main, and actually what we need to do is generate our code. So save that and I'll generate it. And then what we should see is, we might not see any interrupt code here. We'll see it down here. So this is basically setting up our external interrupts. So that I'll initialize that. And if we go over to our folder, our file explorer, select source, and then this IT file, underscore it.c is the interrupt file. And if we look in here, we can see this function. Now, we need to copy and paste this function and move it, but we'll not do that yet. What we can do is set a breakpoint and go back to our main, and we can test this is working first of all before we go and move any code. So if we switch to the debug perspective, what I'll do is I will set an overlay so that you can see me pushing the button, and hopefully we should end up bouncing into our breakpoint in here. So if I go back to our main, what we can do is where is it? If I run putty, we'll be able to see, it won't be reading anything because I don't have a sensor hooked up to it or the ADC hooked up to anything, so I'll read random data, but it's just to show that this will go into the interrupt and pause. So everything's set up and running. If I hit the user button, okay, it's went into our interrupt, and if we look on putty, it's stopped printing. So it's left the main loop and jumped into this function, and then what this will do is this will run whatever we want it to run in here and then bounce back into our main function. So if I hit play again, it'll leave this and continue printing. So that's all well and good. Now what we want to do is we want to move this into our main function, and the reason we want to do that is because in our interrupt function, what we don't want to do is loads of heavy lifting. So we don't want to do any major processing or anything like that. Generally, the best practice is to set a boolean, like a variable, to true or false in here, and then if the true or false is set, the rest of the code can handle it. But we need to be able to access that. So the handy way to do that is if you copy this and put it in the main function down here near the end, and this user code begin 4, paste it in there, and then what we can do is go back to our IOC file. Well, actually stop debugging first and go back to our IOC file, and then in here we can go to mvic code generation, and if we stop that and that, then it won't regenerate that function for us, but it'll still be able to go into that interrupt function in our main.c, and we'll double check this again. So we can actually check that it's removed it if we go back into our interrupt file and it's no longer there. But if we go to our main, we've moved it in here. So because it's in this user code begin section, it won't get overwritten. And if I hit debug, and if we do the same again, then if we hit play, we will be in the main function in our while loop. So if we just hit a breakpoint there, we're in there, I hit play, keep going. So that's just showing that we're in there. Oh, we can see in putty too. Still printing. Okay, and if I hit the interrupt button, so it's come back down into this function down in here, and it's stopped updating this as well. So now with that all set up, what we can do is start doing some funky stuff. As I was saying, I want a boolean flag because I want to just set a variable in the interrupt and then exit, and then in our while loop we can perform the code in here whenever the flag's set, and then we can set it back to false again. So if we, what I can do is create a variable, a pointer to our hello world function or string that we can bring back from the first or the second tutorial. Carriage return, line feed, and we can take our UART data, so if our flag is true, then we can print this hello world data, and it should be like 14 or 15 characters in that variable, and we set the flag to false again, So I need to actually add these variables. So what we need to do is include, not variables, we need to add in the data type for the boolean. I believe it's std bool. And these should be, yep, okay, they're there. So if it's true, it's 1, if it's false, it's 0. So all we need to do now is create this. We need this as a global variable. So these have all been local variables for this main function. But now what we need to do is create this as a global variable. Global for this file. So if I look for any private variables here. So if I do static, static just means it won't be able to be called from any other files other than just this one. So flag is equal to false initially. And we'll just put underscore s so that we know it's a static variable, static bool, I should say. Yep. And then if we put this flag down in our function, basically what this should do is whenever the button's pressed, it should print hello world. But if it's not pressed, then it should just keep printing our ADC values. So what happens is if we press the button, it should print hello world as well as printing our ADC values. But if the button's not pressed, it won't print the hello world. So if we go and set this down here, use your code begin, flag equal to true, and then we can watch this on putty rather than the debugger. So if we hit play, open putty, we'll keep printing this data, and then press the button, it's printed hello world. Oh, it got rid of it. Did I get rid of it? Why did it do that? That's weird. That's really weird. Okay, I don't know why it's done that. So I was having problems there printing out my data, and it was because I had miscounted the number of characters in this string. So it was actually 15 instead of 14. So because of that, I was having problems when printing out. When I went to print, the data was appearing and then it looked like it was getting overwritten, and it seemed to be to do with the fact that my new line feed character wasn't being sent to the UART or sent out over the UART. But now that that is fixed, what I can then do is show you. I'll just rebuild this. It's the same code with a 200 millisecond delay instead of a 1 second delay, and the buffer size set to 15 instead of 14. And if we press play and look back at our terminal, what we can then see when I press the button is it'll print hello world, and then I'll go back to printing the ADC value, and I'll just keep doing that. So that's basically how you get interrupts set up and running with your ST micro. And I'm not sure what else to do. I'm gonna do a free RTOS video as well, but other than that, I can't think of anything else to do. I could do an I2C or on the SPY video, but we'll see how these go. That's me for the rest of the day anyway. I'm gonna go now and chill out. So until next time, bye bye.